All right, athletes, we're in 7.4. We're going to look at zeros of a polynomial. So let's take some notes here.
In this video, we have f of x equals x to the third minus 7x squared plus 6x plus 20.
All right, so we have this function, and we want to know where does it cross the x-axis. So that's what it means when it's a zero. When does when does the y value, the function, equal zero for which x values? And I'm going to give you a graph. I'm going to show you a shortcut at the end of this video. But first, you have to understand what are they asking in order for them to understand like when to use this shortcut, how does it work, and you're still going to have to show some work, but this is going to help us move much faster. All right, so go ahead, take some notes here.
We want to find all the zeros of the polynomial. Well, I can't see any way to factor the expression using the standard techniques of factoring. So the only new tool we have is to search for rational zeros and hope that we find one. From the rational zero theorem, the possible rational zeros are given by the ratio of factors of 20 divided by factors of a leading coefficient of 1. Factors of 20 are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. The factors,
again, factors, these are all the numbers you could divide into 20. Okay, so these are all the numbers, the positive and negatives, right, that go into 20. And we're going to do the same thing for this one, but that's easy.
So the leading coefficient are simply plus or minus 1. So the possible rational zeros are all the factors from the p list divided by the values in the q list, which are plus or minus 1. So the list p over q is plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. At this point, we just need to start testing the values to determine which, if any, are zeros.
And I'm going to show you again at the end of this video a shortcut so you know which one of these or which ones are actually zeros. All right, so again, once you get your p values, you divide them by your q values here. All right.
So I'll start with 1. I'll set the synthetic division. I'll bring down 1. Then 1 times 1 is 1. Adding negative 7, we have negative 6. Negative 6 times 1 is negative 6. And added to positive 6 gives us 0. And 20 plus 0 gives us a remainder of 20. Since the remainder is not 0, then x equals 1 is not a zero of the polynomial. So let's test negative 1. I'll set up the synthetic division.
Again, what we're looking for is our zero, so we're trying to see which one of these c values here is going to give us a remainder of 0. All right, so that's what we're after. And again, you're going to get really, really fast at this. Okay.
I'll bring down 1. Then negative 1 times 1 is negative 1. Adding this to negative 7, we have negative 8. Negative 8 times negative 1 is 8. Added to 6 is 14. Then negative 1 times 14 is negative 14. Added to 20 gives us a remainder of 6. So x equals negative 1 is not a zero of the polynomial. So we would have to go through the entire list of p over q values, and we're not even guaranteed that any of these will work. However, I continued through the list and found that x equals 5 is indeed a zero of the polynomial.
So notice what you just said. None of these are guaranteed to work. So you just keep going through all the plus and negatives until you get one that works. And that might seem like a long time. So again, this is why I'm providing you with the shortcut. But again, I want you to see what you're after and what it means.
When we divide f of x by x minus 5, we have a quotient of x squared minus 2x minus 4 This means f of x factors as x minus 5 times the quantity x squared minus 2x minus 4. Now remember that zeros are the values of x for which f of x equals 0. Since the second factor is a quadratic polynomial, we can find its zeros from the quadratic formula. So I'll set f of x equal to 0, and the zeros of f of x are the solutions to x minus 5 equals 0, and x squared minus 2x minus 4 equals 0.
So again, what's nice about this is not only does it tell you that x equals 5 is a 0, but here, whatever you're left with is also a 0. So here I get two zeros. I'm going to get two functions equal to 0. I'm probably going to have to use a quadratic formula here, but at least now it's much easier to see what my 0 is. All right, so this isn't going to give you all your zeros like in terms of like clean values. So you still have to do some work. All right, and I'm going to show you how to do that work because here again you're going to have to use a quadratic formula because this isn't factorable to see if you have two other zeros. All right, so let's take a look.
The second equation is quadratic. It's not factorable over the integers, so I'll use the quadratic formula. So x equals the opposite of -2 plus or minus the square root of 2 squared minus 4 times 1 times -4, and this is all over 2 times 1. I'll simplify to get 2 plus or minus the square root of 20 all over 2. The square root of 20 equals 2 times the square root of 5. I can factor out a 2 from the numerator. We have x equals 2 times the quantity 1 plus or minus the square root of 5 all over 2. So x equals 1 plus or minus the square root of 5. The solutions to the equation f of x equals 0 are the zeros of the polynomial. So we have 5 along with 1 plus or minus the square root of 5. Now I want to make one final comment. The value 5 is a rational number, whereas the values 1 plus or minus the square root of 5 are irrational numbers. If we had tried the other values in the list, p over q, from the rational zero theorem, no other values would have worked. That is, 5 is the only rational zero of the polynomial.
All right. So again, this irrational value is gonna be impossible to get with the shortcut that I'm going to give you. But again, the shortcut that I'm going to give you, what's going to happen is it's going to help us get to the rational answer much sooner. All right. So again, give me after this next video, I'm going to show you how my shortcut is going to tremendously help you. All right. So again, let's take some notes here. And let me just move Toby to the other room because you hear all the noise behind me. So let me just get Toby, my dog, in the other room. All right, so here we're gonna use the same idea to find the zeros of this function. All right, and then I'm gonna show you the shortcut after this.
In this video, we have m of x equals 3x to the fourth power minus x cubed minus 36x squared plus 60x minus 16. We need to find the zeros of the polynomial. This polynomial doesn't factor using traditional techniques, so my only hope is to use the rational zero theorem. The possible rational zeros are the factors of -16 over the factors of 3. The factors of -16 are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, and plus or minus 16. The factors of 3 are plus or minus 1 and plus or minus 3. So the list of values p over q is plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16, or plus or minus 1/3, plus or minus 2/3.
So notice what she's doing now. So you have all these values that were divided by 1, so nothing changed. But now you're going to take all these p-values and divide them by the 3. So this is where all the fractions are going to come from. All right. So make sure you write that down, because I'm going to ask you for that list.
Plus or minus 4/3, plus or minus 8/3, or plus or minus 16/3. Well, this is a long list, and in videos to come, I'll show some techniques by which we can sometimes shorten the list of choices. For now, I've already gone through and tested the values in the list, and have found that x equals 2 is a 0. I'll verify this and set up the synthetic division. I'll bring down a leading coefficient from the dividend, which is 3.
All right, so notice she said she tested it. But what I'm going to ask you to do is go to decimals.com and go ahead and type in this function. So I went to decimals.com, and it's a graphing app, right? And I went ahead and I plugged in that function, and it gave me, right, my polynomial here. And what's nice about it is I could see where my zeros are. So if I zoom in, right, I could see I'm going to get 1 0 at -4. I'm going to get another 0 that's going to be hard to read right here. So I don't know that exact value, but I could see that I get another 0 at 2. All right. So notice if my 0 is at 2, right, that's where that 2 came from, right? So I could use this graph to kind of grab some of the easy zeros right away. So again, it won't tell me this one because this one would probably be irrational, I imagine, but it's going to tell me this 2 and this -4. So again, this graph using decimals, which I'm allowing you to do, is going to save you time. All right. So let's go back to the video.
Then 3 times 2 is 6. Adding this to -1, we get 5. Then 5 times 2 is 10. Added to -36 is -26. And 2 times -26 is -52. Added to 60 is 8. And 8 times 2 is 16. And 16 plus -16 is 0. At this point, we've verified that 2 is a 0 of m of x, and that x minus 2 is a factor. Therefore, m of x equals x minus 2 times the quotient 3x cubed plus 5x squared minus 26x plus 8. At this point, we need to factor and find the zeros of the quotient. Since the constant term of the quotient is 8, then in the list of values p over q, we can eliminate any possibilities that involve 16. So I'll cross out plus and minus 16 and plus and minus 16 over 3.
Okay, that's a good technique she's using, but again, we could kind of use my shortcut. And now see where these lists, this list is a 3, -1, -36, 16, -16. So your new list, we're going to do the same exact thing we just did here, but now we're going to use the 3, the 5, the -26, and the 8. But using the shortcut, I could see going to decimals that -4 is also going to work. So I think you're going to hear her right now say that, oh, -4 works.
I want to further factor the quotient, so I'll look for rational zeros first. Now, we've already found that x equals 2 is a 0, but it may be a repeated 0. That is, it may be a 0 with a multiplicity greater than 1. So I'm going to test x equals 2 again. And I'm going to use a row of numbers representing the quotient from the previous synthetic division. I'll bring down the leading coefficient 3. Then 2 times 3 is 6. And adding 5 to this, we get 11. Then 2 times 11 is 22. Added to -26 is -4. Then 2 times -4 is -8. And 8 plus -8 is 0.
So notice you get another 0. So how did she even know that the 2 would work 2 times? All right. So one thing I want to show you from our graph, notice once we approach 2, see how the graph is getting closer to 2 and it touches 2 and it bounces back? If I zoom in here, notice that looks like a parabola to me right here. If I were to zoom in really close, right? Doesn't this look parabolic right here? Whenever you get the graph approaching a number and then bouncing right back up, what that tells me is that this 0 is going to have a multiplicity of 2. It's going to be an even multiplicity. It could be 4, it could be 6. We'll talk more about that later. But it's going to have at least 2 copies of it. So this is going to be a 0 at least twice. Again, that only happens when it approaches that number and then it bounces right back up. So let's say it was coming from down here. So if it were coming from down here, my graph, and it touched 2 and then went right back down, then that would also tell us that the 2 would repeat itself. All right. So again, whenever it looks like a parabola, like a U or an upside down U at that 0, then what that's going to tell you is that this number is going to repeat twice. All right. So make sure you write that down. So notice now we have another function here, and it's going to be x squared, x, and the coefficient. So this is going to end up being a quadratic that hopefully I could factor. Let's see.
So we know that x equals 2 is a repeated 0, and that x minus 2 is a repeated factor. So we can factor m of x as x minus 2 quantity squared times the quotient 3x squared plus 11x minus 4.
And notice it's x minus 2 squared because the x minus 2 is a factor twice, right? There's 2 copies of it, so that's why it's squared. And then this is giving us this quadratic right here that she's writing down.
The zeros of m of x are the values of x that make this expression equal to 0. At this point, we no longer have to search for rational zeros. This is because we can find the zeros of the quadratic polynomial either by factoring and applying the zero product property or by using the quadratic formula. In this case, the trinomial factors as 3x minus 1 times x plus 4. So m of x factors as x minus 2 squared times 3x minus 1 times x plus 4.
And notice the x plus 4, right? The c value is -4. So looking at my graph again, let me zoom out. Let me move it over here, zoom out. There's that -4. And then I could also see, going to my graph or to my function, when I solve this, when I set this equal to 0, I'm going to get 1/3. And so here, this value right here is 1/3, right? 0.333 repeating. All right. So again, you can see the value of graphing it on decimals.
Okay, so now with m of x factored, it's easy to solve the equation and identify the zeros. The zeros are x equals 2, x equals 1/3, and x equals -4. And I should note that x equals 2 has a multiplicity of 2, whereas the zeros 1/3 and -4 each have a multiplicity of 1.
Right, athletes. So hopefully that helps you out. And again, these shortcuts is gonna, instead of you testing all these values, it's gonna save you so much time. So hopefully you enjoyed this video, and I'll talk to you guys next time.